Hi, I'm Josh Goldberg. Welcome to TypeScript for APIs. You can find the slide notes, alt text attributions, link to repositories on my website, joshuakgoldberg.com. The presentation, I want to note, also includes a lot of looped animated images, and if those are distracting for you, I'd also recommend viewing them in the PowerPoint viewer online, which can pause them. Little introduction first. I'm from upstate New York. I'm a front-end dev at a tech ed company called Codecademy. I have 5 cats with my wife. My favorite is the one in the middle, Brad. He's a cutie. I'd like to talk to you today about how you can use TypeScript as an API author to improve your API's stability, usability, and development scalability. First, we're going to go over what TypeScript is in the first place, how we can improve your JavaScript code, its authoring experience, how folks use it, agnostic of which JavaScript variant you're actually writing in. We'll then move on to definition files, which are a TypeScript feature that enable JavaScript and TypeScript authors alike to reap the benefits of a strongly typed API, as well as the backing DefinitelyTyped service that powers definition files for a lot of non-TypeScript libraries. We're going to then talk about systems such as TypeDoc that generate full HTML documentation from your source code's types, which is pretty nifty. After that, we'll take a step back from granular code writing and look at Swagger and GraphQL, which are 2 incredible technologies that can automate and validate large amounts of your API development and usage for you. It's going to be a fun ride, so buckle up. A lot of stuff. Anyway, TypeScript. TypeScript is a superset of JavaScript. It is specifically a typed superset of JavaScript. This is a catchphrase many of you might have heard, but what does that actually mean? One core premise of TypeScript is that your source code will be transpiled or turned into JavaScript with any TypeScript-specific features such as type annotations erased. If your code contains TypeScript constructs such as that :stringer undefined type annotation, they get erased during type compilation so that only the JavaScript constructs remain. By the way, that little question mark dot operator, also known as optional chaining, is a fantastic new JavaScript feature that TypeScript supports. Highly recommend. TypeScript makes use of those type annotations to help itself understand what possible values could be stored under each object in your code. For our example so far, the type system will understand that we've declared a variable named trimmed_length with a value equal to a function that takes in a single parameter of type stringer undefined and returns a value of type stringer undefined. TypeScript was told the parameter type by us and thus was able to infer the return type based off of that type and the rest of the code. If we were to say, call trimmed_length with a number in our code, TypeScript would know to give us little unhappy red squigglies in our editors because that's known to be not allowed. The type system code and other type system inferences are development time only construct, meaning they aren't included in the output JavaScript, but they do help us greatly describe and improve our code, both to ourselves and our understanding and for other people who are trying to use the code. So in a way, it's a pleasant cycle where TypeScript helps us improve our output code descriptions and usability, which then helps the code itself. By now, we've talked about what TypeScript is, but I admit I still haven't answered why TypeScript. What's the point? In a phrase, TypeScript helps us avoid surprises. No one wants to be surprised by how a system works. When we're hooking up to an API, we want to know exactly what are the inputs and what are the outputs. What am I supposed to do? What am I not allowed to do? If I just start writing code, is that going to work? We need standard formats to describe these functions, these APIs that we're using, because otherwise it can be very confusing to try to figure out how an API works. Every company has different documentation and development practices, and it's a nightmare trying to use an API that's not documented well. Don't be like the monkey. Consider the development of a typical full stack application with code ranging from the front end, the areas users see and interact with, up through a client SDK that talks to APIs handled by a server controller, down to the backend server logic. Each part of that application is its own mystery for development. We're all developers here. We know every part of the stack has its own difficulties. No part of the stack is better or worse than the other. Yay, front end. But the interaction points between those stack areas are themselves a key confusion source. People writing front-end logic might not be talking to the people writing the client SDK. And even if they are the same people or talking, it can be confusing switching between areas, remembering how all the APIs work. The first tool we're going to talk about today to help with this is the concept of a definition file from TypeScript. A definition file is a piece of TypeScript syntax that defines the objects in a JavaScript file or module. In here, we see a definition file or a DTS file, definition TypeScript, that says a few things. This myAPI function declared in a @my/API module takes in a query string and it returns a promise. Specifically, that async result, that promise, is either an error or an array of objects, where each of those objects, which we're going to colloquially call my result, contain text and title strings. Cool. Now, you don't need to change the way your code works to use these definition files. In our index.js, which looks suspiciously like JavaScript syntax because TypeScript is a superset of JavaScript, we see that myAPI from @my/API is used like a JavaScript module. This DTS file is separate. But if you're looking at the code and scrutinizing, you might know that there is a potential for error in this code. And this is where TypeScript really comes in handy. Because if we're using TypeScript, TypeScript can tell us, wait, hang on a second, this results member is either an error or an array of my results. And we're not handling the error case well. So TypeScript can give us a little red squiggly in the editor and tell us, hey, you need to handle that case. You need to narrow down whether results is an error or an array. And because TypeScript has an awesome type system that can make cool little deductions about your code, now this thing won't give us an error. Hooray, yay. Fun fact about this, you might be a TypeScript developer already, sort of. VS Code ships with built-in TypeScript typings files for built-in objects and browser globals. This is part of this whole system called Intellisense, which is enabled even for JavaScript files without any configuration on your end, where the little drop-downs that you get when you start typing in names are informed by the TypeScript understanding, or whatever language server is in your language, of what's allowed. Furthermore, in addition to shipping with built-in TypeScript typings for things like window and document and console, if a package has DTS types as part of its node module distribution, VS Code will use them too, which is pretty awesome. So just taking a look at a VS Code editing experience, we see that if you start typing in, say, document@event_listener, TypeScript has told VS Code, hey, this is allowed to take in a few different things. If you add in blur, it's a blur event, meaning a function that is allowed to be called with an event optionally. If we call console.log, then TypeScript tells us, hey, console has log, error, warn, and so on. It's pretty nifty. And there's nothing you need to do as a JavaScript developer to enable this. Just use an editor such as VS Code that supports TypeScript. Sweet. Coming back to the Surpriso chart from before, there's no drastic system change needed for this stuff. Client SDKs aren't suddenly talking directly to server logic. But I'd like to think that there's a little easier step in all of these things. The interaction layers between different areas become easier if they have DTS files written for them. And later on, we'll look at how we can do that. Furthermore, each area of code gets a little easier to write because packages, libraries, built-ins are a little more usable, a little more understood. For this, I award definition files, one small rocket emoji for each area of code. To the moon. DefinitelyTyped. We've talked about using DTS files, but where the hell do they come from? Do we have to write them ourselves? What's going on? So DefinitelyTyped is known as the repository for high-quality TypeScript type definitions. Not every TypeScript package author writes DTS files. Many of us, perhaps even most of us, don't know how to write a good DTS file, which means that if we want to use them, we need to welcome people in. We need to make a communal repository where folks who know DTS can share type definitions for common libraries. This thing exists, and it's called DefinitelyTyped. It's a huge repository on GitHub, one of, if not the most active repositories, depending on your metrics. It is awesome, and it's under DefinitelyTyped.org. It auto-publishes packages written by the community for each common library under the @types folder on NPM. So you can install @types, say React, as a development dependency in your app, and then it'll be added under node modules /@types/ whatever the package name is, say React. TypeScript will know to check under these @types areas if a package doesn't contain its own DTS definitions. For example, Facebook's React does not, but you can still get really good Intellisense for React by including @types/React. Furthermore, if you're not sure whether a package has its own types, if you need to install it, if they exist in the first place, go to aka.ms/types. That's a URL. And there's this dope little type search package. Shout out to me. I helped write it. It's awesome. I'm a really big fan of this. It's a sweet little real-time search that lets you see for each package whether the types exist separately, how to install them with particular package managers, and how popular they are. Try it out. For this, we get the same benefits as before. We are now filling out definition files in more places. If we had front-end logic with React, now we get nice little React development time information. And that, I think, is the first real step towards becoming a TypeScript developer for a lot of us, learning to love and perhaps even rely on those little IDE squigglies. So for this, I award, yet again, little rocket ship emojis of size small to each area. And I suggest to you, if you're not already a TypeScript developer, just try it. Add a few @types packages as a dev dependency and see how you like it. Next up, we're going to talk about documentation generators, specifically one called TypeDoc, which takes in your TypeScript code and converts it to HTML documentation. This is key and excellent because people really, really care and want good documentation. For a public API, if someone isn't able to find a good docs website for it, the chance of them using it or enjoying it if they do, much smaller. Because who has the time to sift through an API? But at the same time, if you're making an API, if you're releasing a client SDK, if you have some code you like to ship, how do you have the time to make a full-on website for that? And then if you do have the time to make a website in the first place, do you have the time to keep it up to date as your code changes? There's a lot of effort involved in making a good handcrafted documentation website. There's a reason why so few public node modules have a good one. Enter TypeDoc. This thing can ease the pain of creating that documentation website for your API or SDK. TypeDoc directly generates HTML documentation or a JSON file that you can use from your TypeScript source code. It factors in comments, type declarations, and inferred types. And it's super duper extensible with themes and plugins support. You can try it out with TypeDoc as a dependency and then running TypeDoc --docs. --out docs, path to some files. I've set up a quick little example here that you can clone, Joshua K. Goldberg /TypeDoc example. You can CD into it, npmi, npm run docs. Once you do that, you'll get a nice little page here. It shows a bare bones example project with a doc site generated using TypeDoc, which I don't know, I like this theme. I think it's cute. People like this type of stuff. Even if it just doesn't, even if it only shows what's in the code and it doesn't really add anything you can't infer from generated TypeScript definition files, it's still a pleasant format for reading. So, pros, this is a nice, fast, and I think relatively quick doc site generation. The docs stay up to date with code if you integrate it into your build process. The site looks really nice and people think you're an incredible documentation writer. And it's also super duper customizable. You can add your own company header and footer or code snippets or whatever. As with any new technology, any new tool, there are some cons. It is yet another framework to learn and depend on. It's not exceedingly useful if you don't comment your code, I find. If it's just a bunch of random interfaces and function names, it can be hard for people to read larger projects. This is stuff, again, that's already available already if you're using TypeScript or generally DTS files. And I want to note, it doesn't directly auto-create your clients. It just tells you what people are already working with. For this, I awarded one medium-sized rocket ship emoji on the client SDK part specifically, because it doesn't completely change your logic. Again, it doesn't really change how anything works. It just elaborates on what these SDKs might look like. In practice, I've seen it mostly used for these client SDKs, but in theory, you could really use it for any library. Still, although it won't change your app dramatically, I like it. I think it's a cute start. So I'd recommend, try it out, see how you like it. For the rest of this talk, though, you're going to want to buckle up and hold on strong because this is going to be a lot of code gen from here on out. We're Switching over to the real fun tools. OpenAPI is a language-agnostic API descriptions and code generation package set, also known as Swagger. I will note I don't think anyone truly has a formalized standard for what OpenAPI refers to versus Swagger, so beware of that. But let's get a little context here. Suppose you have an API and you like client functions to be able to handle it. Let's say you're writing a mobile app and a desktop app equivalent, and there's one API for both of them. Both of their clients need to take in data in the language's preferred formatting, whether that's TypeScript or Swift or Java or Kotlin. They need to send that as a request to the API, and then they need to receive and parse the response. So if you're writing it in something like React Native Expo, you only have to do that really once, but what if you're writing it in 4 different languages? How many times are you going to have to write the same darn client function code? It's a pain in the butt. Enough is enough. Standardization. OpenAPI, most specifically and formally, is a standard format for describing APIs. On top of OpenAPI, we have great tooling called Swagger that exists for 2 common use cases, among others. We can generate code from OpenAPI specs, and we can generate those OpenAPI specs from our code. On the right here, we have a description of a user/login endpoint with type definition ask comments with a summary and a description of parameters. Here we can read through the JSON, which could have been in YAML, that there is a summary that this logs users into the system, and it takes in 2 parameters, both required and of type string. Their names are username and password. Cool. I have another example for you, JSworld-Swagger, which you can npm install and npm run start if you'd like to follow up on home. Instructions are in its README. It also has its generated code checked in, so you can peek at it online or locally without running builds on your own machine, which I find to be useful. The strategy that particular repo is using is the code from OpenAPI, or OpenAPI to code strategy. As I alluded to earlier, these descriptions are somewhat similar to a type system description set, where we declare what exists and what it can take in. Following that, we declare what it can return. So this user login endpoint can be described in client SDK terms as having an interface user login request that takes in a username and password. Then we might say, we want to write a user login function. One of the key things about Swagger is that if there's something very straightforward like this that you might need to do over and over again, Swagger will generate it for you. The example library previously linked to, which again is JSworld-Swagger, has a cute little library, Swagger Express MW, that uses the OpenAPI spec to generate code, both for the client SDKs and for the server itself, which I think is pretty nifty. So Swagger can generate your clients for you. It can take in a description in JSON or YAML and poop out this little snippet of code, which might seem small and trivial in this very contrived example, but trust me, when you have 50 API endpoints and 4 languages to output to, it's a real time saver. Even better, a lot of Swagger code gen works on frameworks that let you describe your code in your code. No one wants to have to manually maintain a separate .json or .yaml file by hand. So a lot of frameworks have developed ways of describing how the Swagger should look in metadata in your code. Here, this is one we use at Codecademy called Grape, which is a Ruby framework that allows you to add descriptions, parameters, resource forms to your code in your controllers. And then Grape will create a Swagger endpoint for you. It'll create the JSON or YAML. In this case, the user login might be described in Grape as having this particular resource definition, which is fantastic because now we don't have any manual documentation files to create or update separate from our code. Everything exists in our code. Furthermore, because this is hooked up to generating OpenAPI specs, this allows us to generate clients as we update our controller code, which is pretty incredible. Big fan, big fan. The really cool thing here is that you might have noticed the code on the left is not JavaScript or TypeScript, it's Ruby. I personally have had great success with NSwag, the TypeScript C# .NET library for using OpenAPI from your controllers. So it's pretty nice to be able to take in code that's in a completely separate language and then generate type definitions for your own TypeScript code or JavaScript code from it. Fun stuff. Pros and cons. Basically, every language and framework under the sun is supported. I have yet to find a major one that doesn't have a moderately good, at least, OpenAPI toolchain, Swagger toolchain. I found the output clients are super duper customizable. The main Swagger toolchains use mustache templates, so you can do basically whatever you want or need with them. I'm a huge fan of automating writing client code because who wants to write that stuff over and over? And even better, you don't even need to generate a full-on client SDK. If you want, you can just use the DTS files for a little extra type safety in IDE Intellisense. Cons, as with every framework, it is yet another one to learn and depend on. I've also found DIY or having to hand set up these things vary a little bit between languages and frameworks. It is a little restrictive, which you might consider to be a pro, in that you can't set up your controllers in wacky, zany, non-standard, non-HTTP RESTful ways. Swagger needs you to be reasonable with them. And then also the main tool chains are in Java, which I think is just the most annoying damn thing. Who wants to write Java? Who wants to get Java to build in Circle CI or whatnot? Whatever, small con. For this, I award 2 emojis. We get a very large rocket ship emoji because the client SDK could be completely auto-generated for us. And we get a small rocket ship emoji on the controller because a lot of the controller logic becomes simpler, better to document, better to understand using this very formulated system. So it's nice. Thank you, Swagger. Our second to last topic is HTTP REST, because in order to really describe why GraphQL is great and amazing, we have to first complain about one of the core pillars network requests have been built on for decades, REST. Representative state transfer refers to a way of building APIs that adhere to good HTTP standards and methods. RESTful, as they're called, APIs, allow you to define the action you'd like to take in your request headers and URI. Then if there is a server or controller to receive that request, that controller uses them. From the developer experience perspective, that last little bit, that one API per request, can be painful. Even though everyone in the industry who's been writing APIs knows and supports and has documentation for RESTful APIs, it can be really limiting and really painful that every form of request has to have its own API to handle it on the server. Let's take a look at an example to really explain why that sucks. So let's say that you're writing a book search application, whatever, and you need to find, let's say, novels by genre and then author location. Someone really likes the Seattle subgenre of horror. So someone needs to find all horror novels by Seattle authors. Suppose you're working with a public existing API, some kind of standard pay-to-play free API, whatever. Using the existing common ways to query on a specific type of resource in a RESTful manner, you might have to write 2 queries for this particular request. You might have to get all authors where their location is Seattle. And then for each author, meaning at least 2 requests, because what if there are multiple authors? You might have to get the books where the author is that author, and then the genre is horror. So that could be 2 requests if there's 1 author. That could be a whole bunch of requests otherwise. And then maybe you have a little more control over this. Maybe you can say, I'm not sending 50 bajillion requests from the client. I'll just write a custom API where we can say novels by author and genre, and then have the request send in all this stuff. Great, now you only have 1 client request to make, but what happens if the client request needs to be more complicated? What if the person also wants publishers from Seattle? Because other authors are from Portland and might get published in Seattle. It's a whole thing. So now, using the common existing APIs method, that's double potentially the amount of requests, because not only do we have to filter for each author, we also have to filter for each publisher and get all those books. If we're writing a custom API, we still only have 1 client request, but now we have to update our custom API. And what happens if people keep changing requests? What happens if it's all of a sudden Seattle publishers or authors, or if it's novels that have sequels? Like what how can we possibly keep up to date with client requirements if we constantly have to add new API endpoints? It's a nightmare. I hate it. It is itself a form of horror. Basically, what I want to be able to do here is run database queries and GET requests. I want to be able to specify, I get a certain thing, sets, whatever, name, ID, title, back from the server, and I want to be able to query basically using like SQL or Mongo syntax. This is a modern problem, and it requires a modern solution. REST is not quite so modern anymore. Now, finally, at long last, I introduce to you GraphQL. GraphQL hardcore enthusiasts would yell at me for saying it's a database request in the browser, but whatever, fine. It's basically a database query with a lot of strict semantics and cool new opinions in it. The client requests now are the ones who define input and output. They send in these very specific formulated requests, and the server interprets that as a query and sends back the equivalent data. This whole query here is based off of a schema that's defined on the server and then told to the client at development time so that we know exactly what we're allowed to query on from the client to the server. It's pretty nifty. Oh, pardon the typo, that's code from GraphQL. I have a JSworld GraphQL example repo with a server and client you can use. It's built on Apollo, which is a pretty popular GraphQL framework and library. When you start it running locally, the localhost server has a pretty sweet playground available that I didn't realize I was missing out on, having only worked in Gatsby and Next for my GraphQL shenanigans. But on the left, you can write your query, and on the right, you get the results of it. Now, you might notice this little red line on line 5, because there is query validation. Based off the GraphQL schema defined on the server, we can tell you when your query is improperly run. For example, if mission is an object, you need to specify what fields come from it. The fact that we even know in the client that mission is a specific allowed entity on the server is pretty nifty. Because now we can get the results back from the client using specifically mission.patch and name, and then the site for these launches, whatever form there is. And on the back, on the right side, we return JSON. And this JSON has exactly what we asked for. No need to write a new API handler, no need to write fancy new libraries. We just have standard GraphQL queries that return what we want the way we want it. Beautiful. Now you might be asking, this is a lot to talk about that's not TypeScript, but do you see how these ideas are beautiful and synergistic and resonate well with each other? It is inaccurate to say that GraphQL is to queries as TypeScript is to JavaScript, because GraphQL is a different beast. It's a new way of writing queries, but it shares a lot of the core ideas and benefits of TypeScript. Its consistency and predictability and developer tooling awesomeness ability that are key tenets of both of them. I will also note that GraphQL schemas are pretty great with TypeScript. If you have a GraphQL schema defined in your code, and by the way, this is how you might define a GraphQL schema, you can define the types that are allowed to be sent back from the server. We might have a launch type with a site, mission, rocket, is booked. And then those are pretty analogous to TypeScript interfaces. And there are pretty cool toolings that exist for generating TypeScript interfaces from your GraphQL schemas. So instead of exposing an API with manual RESTful calls for every possible type of resource that exists, I'd highly recommend try out the example code, maybe try out one of the fundamental GraphQL libraries that exist, such as Apollo, or maybe use a Gatsby starter that comes with GraphQL. And then try it out. Try generating TypeScript types from your GraphQL schemas. It's pretty sweet. For this, I give GraphQL 2 large-size rocket ship emojis. As with Swagger, GraphQL removes the need for a painstakingly handwritten client SDK. And then a lot of frameworks actually allow you to get rid of your controllers altogether, where you have server logic in a database, and a wrapper on top of that database allows you to pretty straightforward manner set up your GraphQL endpoints on top of it, thereby automating both your client and your controller, which is awesome. No more wrestling with parameter validation or request serialization. The entire shebang, that whole line between client and server, gets kind of wiped away for you. In my playing with things like GraphQL on, say, Gatsby or Next, I felt that the line between client and server starts to blur and disappear, where it feels like we just have two applications and we have async calls between them. And then we have super duper power in filling out those API calls with data. So in many ways, GraphQL makes us feel like there really is no line between the client and server. It's just network latency. Of course, we still have the areas of confusion that will always exist in development, the front-end logic and the server logic. And that's, for now, inevitable, but we've made things a lot more understandable. Pros and cons. I love getting rid of that code boilerplates, and it's nice to have just one endpoint that can do basically everything. The request and response flexibility for GraphQL is amazing. We saw earlier that we can define what we want to get back and the queries in our client requests, and then the server automatically does those for us. The development time experience is pretty great too. That playground allows us to validate and preview our queries before putting them into our code. As for cons, yet another framework to learn and depend on, which might be a con bigger than the pros for you if it's just a simple project. GraphQL is still relatively new and evolving. The spec has been ratified and has a whole bunch of companies, organizations supporting it, but it's a relatively new technology. I found it particularly difficult for this talk to prepare TypeScript interface generation from the code, which was a pain. It's also really best when used with regularly structured data. It's not something that's going to, I think, change your login endpoints anytime soon, but for data, it's pretty nice. And in that way, that might also be a pro in that it's pretty restrictive for you. You have to set up your endpoints in this standard manner. Maybe that's a pro, maybe that's a con for you. Let's recap what we've talked about today. First, we went over what TypeScript is and how it can improve your JavaScript code authoring experience, agnostic of which JavaScript variant you're writing in, JS, TS, whatever. We then discussed how definition files enable JavaScript and TypeScript developers alike to reap the benefits of a strongly typed API, as well as the backing DefinitelyTyped service, which powers the definition files for a majority of non-TypeScript libraries. Those libraries can be represented to users with systems like TypeDoc that generate full HTML documentation from the source code, which further documents. We then took a step back from granular code writing and played with Swagger and GraphQL, which are two incredible technologies that can automate and validate large amounts of your API development and usage, removing the need to write a good chunk of your code. Thank you very much to the wonderful conference organizers for setting this up, despite COVID-19 and all the shenanigans in the world. You can reach me on Twitter at Joshua K. Goldberg, and my site again is joshuakgoldberg.com. Thanks, enjoy the rest of the conference. Hold strong to the moon. Cheers.